So, hello everybody. Today I'm going to show you how to use Atmel Studio to development of um, programs for microcontroller. And Atmel is a very useful program for doing development because it has many tools which make it easy for you to understand how your microcontroller is actually working. So let me show you hands-on how to start the program and how to build your first very small application, and you will learn how powerful this application is. So once you have installed Atmel 7, um, I you can go to new, start a new project, and let's make an executable project. It's just a random name, and then we create. So for the creating, we need to define a processor for which you are going to build this project. So the most popular processor now at the moment available is Atmega 328P. So we will just feed this me here, and we will select 328. So here you see a basic structure of a program and how it will look. So we'll just remove some of these unnecessary comments. And so as you can see, this is the main, these are the IOs which have been defined as a basic library. This is the main body of your program, and this is a sort of a while loop which you can run again and again. So just remove this while loop and try to define some variables in C and see how these variables are working. So, so now I have defined variables X and Y, and both of these I have declared as volatile so that memory the processor will maintain these variables in the memory. Uh, Otherwise, these variables get lost after their purpose has been solved. So let's just do some simple arithmetic calculations. X is equal to x plus 2, let's say 5, and y is equal to y plus 2, and x is equal to x plus y. Okay, so it's a very simple program and nothing to do directly with the processor, but how this kind of a small program can be visualized, how it actually operates inside your microprocessor, and the power of the Atmel Studio is what I'm going to show you now. So let's just check if everything is working correctly. Uh, Before doing that, we need to define the processing speed of your Atmel 28. So let's just go into some of the settings for the processor. First of all, I will go to train and the symbol here, and we define the speed of the processor. When we actually start burning the program onto the hardware, these definitions will be very important. But for the purpose of just doing debugging, it is not so critical. So because the nanoboard has a 16 megahertz crystal already soldered onto it, therefore I have chosen a 16 megahertz frequency. If you want, you can select 1 megahertz frequency for your application, just for the purpose of this debugging. Then we go to tools and we define a debugger or program with which will help us to debug the program. So uh, Atmel provides a simulator which helps us to simulate how actual 328 works or any other processor works from the Atmel family. So after we've done this, we close this, we save the program, and we are ready to go. So let's just do a quick compile, F7. So as you can see here, build one is successful. So after this, let me just close the windows for a moment. Okay, we'll just keep this open for a sec. And now let's try to sort of step through the program and see how this program is working. So we click here, and we say see that the program has sort of like execute breakpoint at every single step of the program. So it has gone into compilation or into execution, and nothing has happened at these curly brackets. So we click again, goes here. This is the point at which it starts to actually execute the program, and after this step, as it moves into the next line, this actual line will get executed. So let's click again. So as you can see, x is equal to 10 has been executed here. So if you see the local variables which are mentioned here, x has taken the value of xa, which is actually 10. And if you see the registers, you can actually see that the r is equal to r24, which is the actual current register, has moved um, a, which is also hexa a, which is 10. And here you can see the cycle counts of the which the processor has run. So essentially, this processor has already run 24 ticks. And if you're running at, let's say, 16, or let's say at 1 megahertz, which it says here 1000 megahertz, 1 megahertz, then you would have run 1 microsecond for each cycle, and therefore it says here 24 microseconds. But we've find 16 megahertz, so it should be 1/16th of this value. So means that almost 1 microsecond was taken to do the execution up to this point. But this is the actual cycle count. So let's just step further, and then this line will get executed. So then you see that y is declared as 3. Y is now 3 here. The register is also 3, and it has taken 3 cycles to execute y is equal to 3. Now let's do the addition here. X is equal to x plus 5. Register writes f, which is 16 actually, 15, and this is exactly what we see here in hexadecimal 15. Now y is added to 5, hex 5, hex 5. Now x plus y, and because of x plus y, and this value becomes 20. So 16 plus 4, 20. So this is what we see here. The register value for the current variable x is equal to 20. So this is a very simple, very basic example to show how you can use Atmel Studio, which is a very powerful tool for doing development. And in the future videos, I will show how you can develop more and how these interfaces with the processor status registers, let's say IOs, you can change the view from IO to the registers, how these views help you to optimize your development. Thank you.